Okay guys, Timmy coming at you here, and today I'm going to explain to you the functions of glucagon. Glucagon is a hormone that is the opposite of insulin. So insulin lowers your blood sugar. Insulin lowers your blood sugar. Glucagon raises your blood sugar. So this is important. You should never see glucagon and insulin in the blood at the same time with normal physiology. Because again, the body does stuff that makes sense. And it wouldn't make sense to have a hormone in your bloodstream that lowers your blood sugar and another one that raises it. So glucagon is released from the alpha cells of the pancreas, when your blood glucose is low. So think of it glucagon, glucose gone, right? Not enough glucose. So if your blood sugar is low, what do you expect glucagon to do? And that is, of course, to raise it, and that's exactly what it does. And you're not going to believe this, but glucagon, there are glucagon receptors found on liver cells, and it is glucagon that will stimulate the release of and breakdown of glycogen. And glycogen is the stored form of glucose. Let me show you. So you have glucose here. In times when you're not metabolically active and your blood sugar is elevated, you're not going to need that glucose to make ATP inside your cells. So any excess glucose has to be handled. I told you that free-floating glucose inside a cell will kill you. So this is where the liver comes in. So excess glucose that you ate that's not being used inside your cells to make ATP will get chemically bonded together in the liver and stored with water. Glucose chemically bonded together and stored with water is called glycogen. Glycogen is the stored form of glucose. A couple of other terms you're going to need to know. Glycogenolysis. You'll read this in your book. You'll see this in clinical. Glycogenolysis is the breaking down of glycogen to glucose. And I'll explain that. Again, glycogen is the stored form of glucose. What's glycogen? Glucose chemically bonded together and stored with water, and is primarily found inside your liver. Glycolysis is the anaerobic breakdown of glucose to pyruvate, right? So it's that partial breakdown of glucose once it gets inside the cell to pyruvate, and you make a few ATP. And you do this without oxygen, and that's important. We talked about that. Gluconeogenesis, on the other hand, is taking stuff that ain't glucose and turning it into glucose in the liver. And that stuff is usually amino acids or fat. And it's the glycerol portion of the triglyceride that's actually turned into glucose, and that's in the liver. So those are the hormones that you should be familiar with, or the terms you should be familiar with. So let's do this. All right, again, going to my ever popular two curved lines in a circle, and I'll try to explain this. All right, so watch. You have your bloodstream. All right, little capillary. In this case, you have a liver cell. What does the liver store? The liver stores glycogen, which is glucose chemically bonded together and stored with water. All right, hard question here, coming at you, hard question. What's in a fat cell? Duh. That's right. Fat. And fat cells store fat in the form of triglyceride. We went over this, but just to recapitulate, it's a 3-carbon glycerol molecule, and hanging off of it are 3 fatty acids. And each one of these fatty acids is an even number carbon chain. Right? So this little symbol here represents triglyceride. This is what it looks like. Where do you store triglyceride? In fat cells. Know this, and you know this. Anything that you take in excess amounts that you're not using inside the cells of your body to build stuff or to make ATP will get converted to fat in the liver. That means if you take Joe Weider protein powder and you eat too much of that, those amino acids in your liver in excess will first get converted to glycogen, and you can't store glycogen in an unlimited amount, but you can be as fat as you want to be. That excess is then converted to triglyceride and stored in fat cells. So let's get down to this. So if your blood sugar is low, let's say you haven't been eating for a while and you've been reading the textbook. If your blood sugar begins to drop below 80, that's bad for you. And that's going to be sensed by the pancreas, just like the pancreas sensed when your blood sugar was high. And just like insulin has to bind with the receptor, glucagon has to do it too. So watch. Embedded in fat cells and in liver cells, you have glucagon receptors. Again, when is glucagon released? Glucagon released when your blood sugar is low. So you don't have a lot of what up G's here. So your blood sugar is low. The pancreas is going to sense it, and then the alpha cells of the pancreas are going to release into the blood the hormone glucagon, GL. Why was glucagon released? It was released because your blood sugar was low. What do you want glucagon to do? Well, you want to raise the blood sugar. So when glucagon is released, it will bind to glucagon receptors in the liver. And what that does, and I'm skipping some of the chemistry part, you can thank me later, it will break the bonds that held glycogen together, and it will free up glucose. Now you have these freed up glucose molecules. Where are they highly concentrated? In the liver cell. Where are they lowly concentrated? In the blood. So the freed up glucose is going to go into your bloodstream to raise your blood sugar. And glucagon is going to be released until your blood sugar is back to that homeostatic level of 80 to 100. Now, remember that the only fuel the brain can use is glucose. The other cells of the body can use fat when there isn't any glucose around. So not only does glucagon break down the glycogen stored in the liver, but you also have glucagon receptors on fat cells. So glucagon is going to bind to glucagon receptors on fat cells, and it's going to cause the breakdown of fat, and it's going to dump excuse me, dump triglyceride into your blood. So as a result, fat, triglyceride, becomes the most readily available fuel for the cells of your body, the other cells of your body, to use to make ATP. And you will save the glucose for your brain. And it makes perfect sense. So one of the treatments for someone who has overdosed or who's taken too much insulin and their blood sugar dropped really, really low, because they have insulin in their system already, you're not going to get the release of glucagon, because you shouldn't have those two in your bloodstream at the same time. So what you have to do as a nurse, you have to give them glucagon. So when you give them glucagon, it's going to break down the glycogen stored in the liver to raise their blood sugar. It will also dump triglyceride into the blood so that the other cells of the body can use triglyceride, and you save that excess glucose for the brain, because you need it. Just a couple of other things about glucagon. Glucagon increases your heart rate and increases the force of contraction of the heart. So glucagon can be given for people who are suffering from a beta blocker overdose. A beta blocker blocks epinephrine, and when you're scared, epinephrine's released, and that's going to cause your heart rate and blood pressure to go up. But if you're on a beta blocker, so you block epinephrine from binding to beta receptors in the heart, that's going to drop your heart rate and the force of contraction, so you ain't going to be able to send blood flow to your brain and vital organs. So you can give them glucagon at least temporarily to get your heart rate and blood pressure back up. That's just an aside. You'll learn about that in clinical. But that's really the fundamental effects of glucagon in metabolism. So what you need to understand is that glucagon is released from the alpha cells of the pancreas when your blood sugar is low. Its effects are primarily on the liver and fat cells in metabolism, and when your blood sugar is low, you want to raise it. Where do you store extra glucose? In the form of glycogen, which is glucose chemically bonded together and stored with water. You store that in your liver. So when glucagon binds to glucagon receptors in the liver, it's going to cause the glycogen bonds to be broken, right? And that is going to free up glucose. And when you free up glucose, what up, G? It's now highly concentrated in the liver cells and lowly concentrated in the blood, so it will diffuse out of the liver cells into the blood to raise your blood sugar. The other thing that glucagon does is it stimulates glucagon receptors on fat cells, and that will cause fat to get dumped into the blood in the form of triglyceride. Just so you know, there's a big fancy word for that, and it's called lipolysis. That's a terrible color, Timmy. So glucagon stimulates lipolysis. Yeah, I spelled it right. And that's a fancy way of saying taking and breaking down fat to triglyceride and dumping it into the blood. So remember that the other cells of the body can use triglyceride to make ATP. The only fuel the brain can use is glucose. So the other cells will use the fat, and you will save the glucose that you broke down from glycogen in the liver to fuel your brain. That, ladies and gentlemen, is or are the functions of glucagon.